This is Spacetime, Series 24, Episode 128. Coming up on Spacetime, NASA's Hubble Space Telescope forced into safe mode again, getting ready to launch the James Webb Space Telescope, and Ingenuity undertakes its 14th flight on the red planet Mars. All that and more coming up on Spacetime.
Welcome to Spacetime with Stuart Gary.
The iconic Hubble Space Telescope has switched itself into safe mode after suddenly generating a series of error codes, suspending all science operations. Mission managers say the safe mode configuration was triggered because of a loss of specific synchronization. This message provides timing information the instruments use to quickly respond to data requests and commands. Mission managers have reset the instruments and they have resumed science operations while they try to determine exactly what's happening. This latest glitch follows the triggering of similar science instrument error codes indicating multiple losses of synchronization aboard Hubble a week ago. As a result, these science instruments are autonomously programmed to enter a safe mode state. Mission managers are now evaluating the spacecraft data and system diagrams to better understand the synchronization issue and how to address it. They're also developing a testing procedure to collect additional data from the orbiting observatory, activities which are expected to take about a week. Now, if all this sounds a little bit déjà vu-ish, it is. It's the second major issue affecting Hubble this year. The telescope was offline for nearly 5 weeks back in June when a payload computer which commands the scientific instruments suddenly malfunctioned. That forced mission managers to perform a complete transition to a backup computer. Hubble was launched aboard the Space Shuttle Discovery on STS-31 back in April 1990, more than 30 years ago. The 11,110 kilogram school bus-sized observatory is in a 540 kilometre high orbit. Its 2.4-metre mirror studies the universe in near-infrared, visible and ultraviolet light. Lockheed Martin built the telescope, which is based on the National Reconnaissance Office's Crystal KH-11 spy satellites, the first of which was launched in December 1976. This is Spacetime. Still to come, getting ready to launch the James Webb Space Telescope, and Ingenuity undertakes its 14th flight above the surface of the red planet Mars. All that and more still to come on Spacetime. Well, it looks like all systems are go for next month's launch of NASA's James Webb Space Telescope. The 6.5-ton observatory is slated to launch aboard an Ariane 5 rocket from the European Space Agency's Kourou spaceport in French Guiana on December the 18th. James Webb will be placed in the Sun-Earth Lagrangian L2 position, 1.5 million kilometres away on the Earth's night side. The James Webb is designed to succeed the iconic Hubble Space Telescope. Its primary mirror comprises 18 hexagonal mirror segments made of gold-plated beryllium, which combine to create a 6.5-metre diameter mirror. Unlike Hubble, which studies the universe primarily in visible light wavelengths, dipping into the near-infrared and near-ultraviolet, James Webb will observe primarily in mid-infrared, reaching only slightly into longer wavelengths of visible light. That's because James Webb's designed to look further back in space-time than Hubble, going back more than 13.4 billion years, where it should be able to see ultraviolet light coming from some of the universe's very first stars. Now, this light will have been stretched or redshifted into the infrared range of the spectrum by the physical expansion of space-time itself. It'll allow the James Webb to study astronomy and cosmology in unprecedented detail, observing some of the most distant events and objects in the universe, including the formation of the very first galaxies. But getting James Webb into space will be a complicated procedure. James Webb is the largest and most complex telescope ever sent into space. It's a technological marvel, and by necessity getting it up there will also be an unprecedented risk. Webb's launch will trigger 29 days of events, during which thousands of parts need to work correctly and in sequence in order to unfold the telescope and put it into its final configuration. Each step will be controlled meticulously by mission managers on the ground, as this report from NASA TV explains.
This is a science mission on par with Apollo missions, Space Shuttle, International Space Station, and Hubble missions. For nearly 2 decades, thousands of people around the world, many spending their entire careers, built the James Webb Space Telescope.
Once we launch the James Webb Space Telescope, there are no second chances. We have 300 single-point failure items, and they all have to work right. When you're 1,000,000 miles away from the Earth, you can't send someone to fix it.
We've never put a telescope this large in space. We want to see distant parts of the universe humans have never seen before. Looking back in time, almost 14 billion years, to see the first galaxies that formed after the Big Bang. And we want to search for the building blocks of life in the atmospheres of planets orbiting distant stars. To unfold the history of the universe, we must first unfold this telescope.
This is the largest primary mirror, the largest sun shield, and the most powerful space telescope ever built. And yet, this large telescope needs to fit inside a 5.4-meter diameter rocket fairing. That's the largest fairing size available on any rocket, and it's the fairing size on our ride to space. The Ariane 5, provided by the European Space Agency, is one of the world's most powerful rockets. To cheat the fairing size limit, we built Webb to fold, like origami, to fit inside the rocket fairing.
And this brings us to our most challenging part of this mission, unfolding it in space.
6, 5, 4.
Think of what you're doing. You're taking this extraordinarily delicate, precise, state-of-the-art scientific instrument, you're slapping it on a rocket, and for the next 8 minutes, the explosion from that rocket is following you into outer space. Vibrating you, shaking you. Everything that goes into outer space has to live through this environment and work once it gets there without having someone come to fix it.
Two weeks. That's how long it will take to fully deploy the Webb telescope. We can take longer if we need to, but those 2 weeks after launch are going to be nail-biters. This is the Mission Operations Center at the Space Telescope Science Institute in Baltimore. Those 2 weeks after launch will be like our Super Bowl, World Cup, you pick the analogy. Years of training comes down to these moments.
The Webb Observatory has 50 major deployments, 50 depending on how you categorize them, and 178 release mechanisms must work to deploy those 50 parts. Every single one of them must work. Unfolding Webb is hands down the most complicated spacecraft activity we've ever done. Then again, nothing about Webb is easy. We've never done any of this before. There's nothing simple about sending anything into space. You can't do it without taking risks.
This mission is squarely in new spacecraft territory. Webb is the perfect example of science desire driving engineering capability to new frontiers. Webb's unique design was born from reasoned engineering to accomplish its science goals.
Here's the plan. Shortly after launch, we unfold Webb's solar panel for power and our Huygens antenna for communication. About 12 hours later, we have an important engine firing that sends Webb on the proper course towards its orbital destination, about 1,000,000 miles away. That's where Webb will do its science. Webb will be moving so fast, it passes the moon's orbit in 1.5 days, half the time it took Apollo astronauts to reach lunar orbit. First, we lower the sunshield pallet, then raise Webb's primary mirror and instruments away from the sunshield. The solar wind will push us around with the sunshield open, so we'll unfold a trim tab to help keep us stable.
We got these huge, iconic, golden segmented mirrors that will help us deliver amazing new images from the cosmos. But in some ways, the sunshield is a lot more complicated, and it's just as essential. Without it, nothing works.
Here we've got 5 sunshield layers, or approximately 8,900 square feet, almost the size of 3 tennis courts, a very thin Kapton material, about 1 to 2 thousandths of an inch thick. Making them go where you want them to go in zero-G is extremely challenging.
The sunshield shades the telescope from the heat of the sun, earth, and moon. The concept is simple, but there is nothing simple about the design or operation, especially when you get to space. Webb's sunshield assembly includes 140 release mechanisms, approximately 70 hinge assemblies, 8 deployment motors, bearings, springs, gears, about 400 pulleys, and 90 cables totaling 1,312 feet. All this just to keep the sunshield under control as it unfolds. First, we release these special restraints that protect the sunshield during launch. They roll out of the way, but not all the way until we are ready to deploy a side. Next, we release a set of covers over the core region. Now comes the critical point. All 107 sunshield release mechanisms need to fire on cue. 107. They free the 5 sunshield layers, allowing them to extend as the mid-booms deploy.
With the sunshield fully deployed, we start setting up the optics. First, the secondary mirror is extended and locked into place, and a special radiator behind Webb is extended, which helps further lower the temperature of the science instruments. Finally, we open the primary mirror's wings and lock them in place. With that done, Webb is in its final configuration, but we're not done yet.
After 47 deployments and accomplishing the hardest spacecraft unfolding NASA has ever done, Webb still won't be ready for science.
While the instruments cool, we'll control motors behind each of Webb's 18 mirror segments, a secondary mirror, and the fine steering mirror located inside the center of the primary mirror. We'll precisely align the mirror segments to form a perfect mirror. Then, Webb will be ready to explore the cosmos.
And in that report from NASA TV, we heard from Webb Program Director Greg Robinson, Webb Mission Lead Systems Engineer Mike Menzel, Webb Mission Instrument Systems Engineer Begona Vila, Webb Deployment Systems Lead Alfonso Stewart, and Webb Deputy Director for Vehicle Engineering Amy Lowe. This is Space Time. Still to come, Ingenuity undertakes its 14th flight on Mars. And later in the science report, COVID-19 survivors with 2 vaccination shots show a higher spike antibody level. All that and more still to come on Space Time. NASA's Mars Ingenuity helicopter has undertaken a successful 14th flight over the red planet's Jezero crater. The mission saw the tissue box-sized twin rotocopter undertake its first 2,700 RPM test flight, designed to test the ability of the aircraft to fly during the change of seasons on Mars, which is seeing a drop in air density as the Jezero crater region enters a relatively warm Martian summer. The 23-second test flight saw the 1.8 kilogram chopper climb to an altitude of 5 meters, with a small sideways translation of 2 meters in order to avoid nearby sand dunes. And for the first time, the flight also took a stream of black and white navigation camera images at a faster rate of 7 frames per second. These tests have been designed to see how the aerial reconnaissance platform performs under more extreme conditions. You need to remember that Ingenuity was originally designed to undertake just 5 flights in a program expected to only last a few months following Perseverance's landing back in February. NASA technicians therefore developed the rotocopter specifically to operate at atmospheric densities of between 0.0145 and 0.0185 kilograms per cubic meter. That's equivalent to around 1.2% of Earth's atmospheric density at sea level. But with the mission now continuing well beyond its original design parameters, air densities in Jezero crater are dropping to just 1% of air density on Earth. Now, the difference may seem small, but it has a significant impact on Ingenuity's ability to fly. You see, the chopper has a thrust margin of around 30%. That's the additional thrust beyond hover needed to take off, climb and manoeuvre. But if the Martian atmosphere's density drops too far in coming months, then the rotocopter's thrust margin could drop as low as 8%, which means that Ingenuity would be operating close to what's called aerodynamic stall. One way of tackling this problem is to increase the rotor speed from the current 2,537 RPM up to around 2,700 RPM, eventually even 2,800 RPM. But the higher rotor speeds mean increased dynamic drag on the rotor blades, and that becomes problematic, especially as the blade tips are approaching supersonic speeds, which on Mars is much lower than on Earth. And there's another problem. Ingenuity simply wasn't meant to last this long, and so the issue of parts wearing out, especially parts rotating at high speeds, is starting to become a concern for engineers. Only time will tell how much longer the little helicopter can survive. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has shown that US healthcare workers who caught COVID-19 and then had 2 doses of the mRNA vaccine have ended up with higher spike antibody levels 6 months after being vaccinated than those who had no infection prior to their vaccination. The study, reported in the Journal of the American Medical Association, was unable to determine why there appears to be a greater antibody durability in previously infected people, but it could be due to the number of exposures, the intervals between exposures, or the interplay between natural and vaccine-derived immunity. However, they did find that a longer interval between infection and the first vaccine dose led to a higher antibody response, which supports the idea that extending vaccine dosing intervals ends up giving a greater immune response. More than 5 million people have now been killed by the COVID-19 coronavirus since the deadly disease first spread out of Wuhan, China. However, the World Health Organization admits the real death toll is likely to be at least twice that level, with well over 250 million people now infected. A new study shows that while urban expansion poses risks for many native Australian species, the threatened grey-headed flying fox is learning to thrive in suburban neighbourhoods. Scientists used satellite tracking to follow 98 flying foxes for 5 years to see how they were living in urban and non-urban environments. The findings, reported in the journal PLOS ONE, show that even flying foxes living in more natural habitats were still heading towards human-modified environments for around 26 to 38% of their foraging needs. Flying foxes living in cities have diets that include plants they weren't previously known for eating. That makes tree-lined streets, agriculture and nature patches in suburban areas an inviting prospect. But researchers warn this may be putting flying foxes at risk in new ways, with humans, power lines, fruit nets and suburban heat, all dangerous should they find themselves trapped in the city. Well, it shouldn't come as a surprise that, like all of us, dairy cows have a natural drive to groom themselves and scratch those hard-to-reach places. Now, a new study reported in the Journal of Dairy Sciences found that when given the opportunity, dairy cows will use mechanical brushes daily at every stage of their lives. Heifers began using the brushes almost immediately, even though they may never have been exposed to them before. Cows with no access to brushes tend to rub their heads and bodies against pen walls and the edges of water troughs, and that can cause injury. The findings show that by providing access to brushes in their housing environment proved to be a positive welfare issue for cattle. Elon Musk's plan to blanket the planet in broadband satellite communications continues to grow with his company, now reaching over 100,000 users. With the details, we're joined by technology editor Alex Zaharov-Reutt from ITWire.com.
Well, the news is that Starlink has shipped 100,000 terminals. So they're in the US, in Canada, in the UK, in Germany, in France, Austria, Netherlands, Ireland, Belgium, Switzerland, Denmark, Portugal, and in New Zealand and Australia. But of course, Elon Musk isn't the only provider of satellite broadband. There are many companies that are working on this, and soon satellite broadband
OneWeb has just launched another 34 satellites as well, so yeah.
Yeah, well, it just means that high-speed broadband connectivity will become even more ubiquitous than it is today with various 3G, 4G, and 5G options. But of course, in those areas, in far-off rural and regional areas, or in the middle of the ocean where satellite broadband is expensive, it'll become much cheaper.
What
Only
sort of
a few years
prices are
ago,
they talking about?
it used to be charging $1 a minute or more for voice calls, and now you can pay $10 a month and get unlimited calls and text. In Australia, at least, with 2, 3, 4, 5 gigabytes of data. And you even have Felix Mobile that is charging $35 Australian a month, giving you unlimited calls and text and unlimited 4G at 20 megabit speeds, which is enough for HD streaming of Netflix and YouTube and all of the other services. So in Australia, Starlink is $139 per month. You will need to pay $709 in the hardware fees and $100 in shipping and handling. And then you get speeds between 50 to 150 megabits. Now, of course, that compares with gigabit plans that you can get in Australia and other parts of the world on your fibre to the curb and fibre to the home plans. But those broadband speeds are only going to get faster from space. And at the moment with Starlink, you do have drops in coverage, but as Elon Musk launches ever more satellites as part of his constellation, those coverage problems will go away. But you're looking at speeds that are roughly equivalent to the sort of standard NBN connection you have now. And for $139, that is probably $30 or $40 more than what you'll get paying for your typical NBN connection in Australia. But it is something that gives broadband to people who can't get NBN at all in certain areas, and obviously in the rural and regional areas where fibre is not so readily available and you might not have 5G signals, it can be a real lifesaver. So those prices will come down just as the prices of 5G and 4G and phone calls have dramatically come down over the past 20 years.
Will there always be a place for a landline, or will the future be satellite communications exclusively?
Well, there'll always be a place for landlines because you've got fibre connections coming to your home. I mean, I always used to say that wired is better than wireless. But of course, we've had wireless catching up at a great rate of knots over the past few years. And, I remember when I used to have a telephone cable stretching from one corner of the house to another corner of the house, because those were the days before Wi-Fi. And I wanted to be able to use a laptop computer in a certain room when laptop computers used to come with the modem built in. You'd click in the phone line and connect. But of course, nowadays, Wi-Fi is ubiquitous, 4G is ubiquitous, certainly in major regional areas and all of major cities. And I remember when reading about how in Africa, a lot of African countries didn't have the copper-based rollout, and they went straight from not having any communications to having 2G and 3G phones, of which, African farmers were able to do banking and check weather and do all sorts of things that people in the West take for granted. So, I don't know if it'll exclusively be satellite in the future. I mean, there'll always be a place for fiber connection and different types of Wi-Fi and 5G and 6G and whatever else is coming. But satellite is going to become ever more important, and for some people, they will only have a satellite connection and nothing else.
That's Alex Zaharov-Reutt from ITWire.com. And that's the show for now. Spacetime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. Spacetime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the Spacetime store for a range of promotional merchandising goodies, or by becoming a Spacetime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more Spacetime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our Spacetime YouTube channel, and on Facebook, just go to facebook.com/SpaceTimeWithStuartGary. And Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.